Now we're going to look at rational numbers as exponents. Personally, I find this easier than working with radicals, and so I hope that you find this helpful. The definition of a rational exponent is as follows. If a is a real number, then a to the 1 over n equals, or is the same as, the nth root of a, where a is a non-negative n, and n can be any natural number. When a is negative, n must be odd. This allows for the domain values to be all real numbers. So some examples of rational numbers as exponents would be 9 to the 1/2, which is equal to square root 9, which is equal to 3. Also, 27 is 2 raised to the 1/3 is equal to the cube root of 27, which could also be written as a negative because it is an odd index, or the denominator on the rational number is 3, which is an odd number. So negative 27 raised to the 1/3 is equal to the cube root of negative 27. Let's write some equivalent expressions using radical notation. So we're taking the rational numbers as exponents and rewriting them as a radical. 16 to the 1/2 is the same as the square root of 16. Now notice that I wrote the 2 here for emphasis, but we would normally not write the 2 as the index. We understand it to be 2 without writing it there. 81 raised to the 1/4 is the same as the 4th root of 81. Remember, we're not simplifying these, we're just rewriting them with radicals. xy raised to the 1/3 is equivalent to the cube root of xy. Now we're asked to write an equivalent expression using exponential notation. So now we're going the other direction. Remember that if you have an index, that becomes the denominator of your fractional exponent. So 8ab will have to be grouped in parentheses raised to the 1 over 5. Now we have this fraction, x squared y over 5, and it is in a cube root. So we would raise that radicand to the 1/3. Now let's look at positive rational exponents. For any natural numbers m and n, where n is not equal to 1, and any real numbers a for which the nth root of a exists, then we have a raised to the m over n, which is the same as writing the nth root of a raised to the m, which is also equal to the nth root of a to the m inside the radicand, or the radical sign. So here are some examples. We have 5 to the 2/3, which would be equal to the cube root of 5 to the 2nd, which is also equal to cube root of 5 raised to the 2nd. You also could write 6 raised to the 3/8 as the 8th root of 6 to the 3rd, or as the whole thing, 8th root of 6, all raised to the 3rd. Now let's practice by writing an equivalent expression using radical notation and then simplify it. So we have 27 raised to the 2/3. We'll write this as the cube root of 27 raised to the 2nd power. We could also think of this as the cube root of 27, but we know that 27 is 3 to the 3rd. And then we could write the outside raised to the 2nd. This helps a lot because then we know that the index and the exponent will divide, and you get 3 raised to the second, which is equal to 9. Let's do the same thing with 36 raised to the 3/2. Remember that the denominator on the fraction is your index, so this would be a square root. I wouldn't even have to write the 2. That's why I'm erasing it. 36 is raised to the third. Now let's think about this further. 36 is the same as 6 squared. So we would have the square root of 6 squared. That would be raised to the third. So simplifying gives us 6, and then the exponent on the outside means we need to multiply 6 to itself 3 times, with a final answer of 216. Lastly, we're asked to rewrite the fifth root of negative 23 raised to the third using rational exponents. Then you use your calculator to find the approximate value rounded to the nearest thousandth. Well, we know that any odd root will give us a negative output. So this is the same as the fifth root of negative 23 to the third. If I rewrite this, I know that it will come out as a negative number. I also know that 23 is raised to the third power, and the index becomes the denominator. So 5 is the denominator, and it originally was the index. If I put this in my calculator, I'll have negative 23 raised to the 5 raised to the 3 divided by 5. And we get a negative number, and we're supposed to round to the nearest thousandths. So 3 decimal places. So it'll be negative 6.562.